Hi, welcome to Unit 1, Topic 2, Video 5, where we're going to take the dot product and look at some examples. So I've got example 1 here. Which of the following vectors are perpendicular to A? So keep in mind when we say perpendicular, we mean that the vectors must meet at right angles. So this being A and this being the other one, creating a right angle. But also keep in mind that the right angle is 90 degrees. So if the vectors meet at 90 degrees, it means that A dot B will be equal to the modulus of A times the modulus of B times cos 90. And cos 90 just happens to equal 0. So A dot B will equal 0. That's the main thing we're looking for. So we ask ourselves, does A dot 2 negative 3 equal 0? Well, and I'll do the long working for this one. 3, 4 dot 2 negative 3 is equal to 6 minus 12, which equals negative 6. So that one's out. I can see that 4 and negative 3 and 3 and negative 4 gives me 12 minus 12. So this one works. Negative 16 and 12 gives me negative 48 and 48. So that one works. 0 and 2 doesn't work because the 0 wipes out everything in the top row, leaving us with 8. So that one doesn't work. And of course, we could have recognised here that we really needed to have a negative because these are both positive to make this work. Find your own example of a vector that is perpendicular to A. Generalise and describe all examples of these vectors. So we know if we have a vector, let's call it B, and let's say that B is equal to B1, B2, we want A dot B to equal 0. So therefore we want 3B1 plus 4B2 to equal 0. Now we can't solve for B1 and B2, and that's okay because we're not expecting to be able to, because we know there are multiple possible answers. So what we're going to do is instead set up a parameter, and we're going to make B2 the parameter. So we rearrange for B1. B1 is equal to negative 4B2 over 3, or negative 4/3 B2. And so now if I say, well, let's let B2 equal 6, negative 4 times 6 is negative 24 divided by 3 is negative 8. So that would give us our first possible answer, which is 6, negative 8. And let's say I let B2 equal 600. Then I'd have 4 times 600 over 3, which is negative 800. And that would be another possible answer. So that's our generalisation, so on and so forth. Now my last question is an interesting one. A dot 0, 0. Well, in fact, anything dot 0, 0 is equal to 0. So therefore, anything is perpendicular to 0. But I think the actual answer here is to consider that 0, 0 isn't really a vector by definition. It has 0 magnitude, which is fine, but it doesn't have a defined direction. So I think in this case we can claim that it's not a vector and this idea and concept doesn't hold. So is A perpendicular to 0, 0? Well, A can't be perpendicular to a dot, so no, it's not. In example 2, we ask what is the acute angle between 2,7 and negative 1,4? And so that means that we're asking what happens when we do A dot B and we use that to calculate cos theta. So we say A dot B is equal to the magnitude of A times the magnitude of B cos theta, and rearranging we get cos theta is equal to A dot B over the magnitude of A, the magnitude of B. And so we'll zoom in here, create a little bit of space. A dot B in this case is going to work out to be on top. 2 negative 1 is negative 2 plus 28, which of course is 26. So I can even move that forward to under there. Whereas the magnitude of A is going to be equal to the square root of 2 squared plus 7 squared, which is the square root of 53. And the magnitude of B will be equal to the square root of negative 1 squared plus 4 squared, which is equal to the square root of 17, because negative 1 squared is positive 1. And so we get 26 over the square root of 53 times the square root of 17. There's a lot of prime numbers in that 53 and 72 situation, so there's not a great deal that we can do to simplify this, except to bring those two together. And so I'm going to have 26 over the square root of 901. And then of course theta is equal to cos inverse of that, and that is 29.98 degrees. So there's example 2. And example 3, use the scalar product to prove that two vectors in the form u equals kv are parallel. So the scalar product. So I think there's a few ways that I can see initially to do this. And one of those ways would be to pick a vector that is perpendicular to v and show it's also perpendicular to u. So any two lines that are perpendicular to the same line must be parallel for that to be the case. But another way would be to define u and v, which is the way I'm going to use. Let u equal u1, u2, and v equals v1, v2. And hopefully you agree that u is equal to k times v, and therefore it can also be written as kv1, kv2. So there's our first thing. And so this means, of course, that u dot v is equal to, and I'm going to use our definition of kv1 times v1 plus kv2 times v2, use these forms here and multiply them across. And that gives me k v1 squared plus v2 squared. So there's our first thing. Now, of course, we want to show that the angle between them is 0. If we have these two next to each other, that will prove that they're parallel. So therefore we say, well, the magnitude of u times the magnitude of v cos theta is equal to this stuff. Now, this is generalized, so it's a bit tricky. But what I'm going to do again is do my magnitudes, where I say the magnitude of u is the square root of k squared v1 squared plus k squared v2 squared. And the magnitude of v is the square root of v1 squared plus v2 squared. And then I have cos theta, and that's equal to k v1 squared plus v2 squared. Now, just as an aside over here, the square root of k v1 squared plus v2 plus k squared v2 squared, that should be k squared. Well, I can take the k squared out as a common factor. I get the square root of k squared times the square root of v1 squared plus v2 squared, and that's just equal to k v1 squared plus v2 squared. So over here, I get k square root of v1 squared plus v2 squared times the square root of v1 squared plus v2 squared cos theta is equal to this stuff here. And that's quite good, because when I multiply two things together, they're both square roots of the same thing. I just get k v1 squared plus v2 squared cos theta equals k v1 squared plus v2 squared. I divide through, that cancels to that. Cos theta equals 1. Theta equals cos inverse of 1, and that's equal to 0. So there is a 0 angle in between them, and therefore they're parallel. Okay, so that's the final part of that video. All the best.